Good day, and welcome back. Welcome back to another session of the previous paper that we were dealing with. We have the first part of it. In the first part is where we were able to cover 8.1.1, 8.1.2, and 8.2. We have covered this section in first part of this question paper. Now we are having the second part. This is where we are going to cover the rest of the question paper so that everything it is clear and everything it is clear to our learners, it is clear to our candidates, and it is clear to those who are writing their technical mathematics from grade 11 and grade 12, and as well as grade 10, because we have this part in grade 10. Then 8.3, it reads as follows. It says, the air pressure of a tire deflated. It means it deflated from 220 kPa, K pascals, at a depreciation rate. Now here it loses air. At a depreciation rate, here it loses pressure, it loses air pressure at a depreciation rate of 4.5% kPa per minute. It means every minute it loses what? A pressure. Now the pressure is going to depreciate from 220 to a certain pressure, which we don't know what will be that pressure after a certain number of minutes. Now 8.3.1, it says write down the initial air pressure of the tire. It means before it deflated, what was the original pressure of this particular tire? Now, if we read here, we understand that before it deflated, the pressure, it was 220 K pascals. That was the initial pressure before it started to depreciate. Then to answer 8.3.1, to write the initial pressure, 1 mark there given for Mahala, you just write 220 kPa. A. 1 mark there. Then we don't have to hesitate to answer that question. 8.3.2. Then in 8.3.2, we are required to determine the air pressure of the tire after 15 minutes. Now we understand this is the initial air pressure. Because of the word depreciation, it means we are going to use the depreciation formula. Where it is not indicated that it is a straight line depreciation, please use a reducing balance depreciation formula. I'll repeat, where it is not indicated if this depreciation, it is a straight line depreciation, like we have here, there was no indication to say this air pressure tire, it depreciate on a straight line depreciation or on a reducing balance depreciation. Where it is not indicated, please learners, use a reducing balance depreciation formula that says A, that is equal to P in bracket 1 minus I close bracket all to power of N. Now, since well here we are talking to the real life situation of depreciation, then A, it can be the cost of an item before it depreciate. Then P, it can be the cost of an item before it depreciate. A, it can be the cost of an item after depreciation. Then N and I, they remain the same. But N in this case, it will be depreciation per minute. How many minutes will it take for this tire to depreciate? In this case, since when we are talking to the real life situation, it means P, it will be the initial air pressure of this tire. Then A, it will be an air pressure after this tire deflated. Then I, it is the rate at which this tire loses air. Then N, the number of, or the time it will take for this tire to lose the air. Then in this case, it says determine the air pressure of the tire after 15 minutes. And we know after 15 minutes, this tire, it will be what? Deflated to a certain what? To a certain air pressure. Then P, it becomes the initial air pressure before this tire depreciates or loses the air. In this case, we are looking for A, which is what? The air pressure after 15 minutes. Then P, now it becomes 220 kPa. In bracket, 1 minus, then I is the rate at which this air tire loses air. In this case, we have 4,5, then we are going to have 4,5 divided by 100%, close bracket. Then it says it loses air per minute, and here we also have what? In minutes. Then we put it as 15. We don't convert it to anything there. Then A, it will be equal to, use our calculators, 220 in bracket 1 minus 4,5, 100 all to power of 15. Then this is going to give us 110 comma, let's say to one decimal place, comma 3 kPa. Therefore it makes sense, because the air pressure after 15 minutes, it must be less than the initial air pressure. Because why? Because of the weight depreciation. That is that. I hope everything it is clear. It is 3 marks here. Let me allocate the 3 marks. 1 mark for choosing the correct formula, 1 mark for correct substitution into the correct formula, and 1 mark for the final answer. Only here it's 1 mark there. Then we continue with our question. We are almost there. Then we have 8.4. 8.4. In 8.4, it says Elrich is saving money to buy equipment for his smaller company to be established in 5 years' time. I'll repeat that. Elrich is saving money to buy equipment for his smaller company to be established in 5 years' time. He deposited an initial amount of 18,000 rands into a savings account that offers 8.5% per annum compounded monthly. It says at the end of the 3rd year, because now in a nutshell it's going to take 5 years, because he's going to establish this company in 5 years' time. Then it says at the end of the 3rd year, he deposit an amount, further deposit of 15,595 into the same savings account, or into the same account at the same rate, which is this rate here. It says calculate the future value of his investment at the end of the 5-year period. Now remember, you must have an idea to say, is the last question a timeline question? How do you tell that the last question of finance growth and decay, it is a timeline question? There are 3 prescripts. 1, there should be more than 1 interest rate. It means you'll be given an interest rate, then after a certain number of years it changes to the new interest rate. If that is the case, it is a timeline. 2, after a certain number of years after initial deposit, there is a further deposit. Therefore, that is a timeline. 3, there is a withdrawal into the same account after a certain number of years. Therefore, that is a timeline question. In this case, we have a further deposit. It indicates that we need to draw a timeline in order for us to answer this particular question. Now, the first thing that you need to indicate on your timeline is the time frame. Now, we start at year 0, T0, or year 0, either way. T0, this is the beginning of our investment. Now, we understand that the establishment of this company, it will take 5 years. It means this investment also, it will take 5 years. Then the number of years for this particular investment is going to be T5, which is 5-year period. Now, after indicating the period, you come to the amounts. Initial, here it says initially he deposit. It means at T0, this is the initial deposit. I'll reach deposit an amount that is equivalent to 18,000 rands. 18,000 rands. Then after the initial deposit, it took how many years for him to do another further deposit? It took 3 years. Then you must go to T3 anywhere here. You must have T3. What is happening at T3? There is a plus. You must indicate it with a plus because there is a further deposit. A further deposit of how much? A further deposit of 15,595. Then after this further deposit, there is no other amount that we have there. Then after indicating the amounts here, you must indicate the interest rates. And we see that the interest rate is the same throughout the number of years. Now from T0 all the way to T5, the interest rate is the same. What is our interest rate? It is 8.5. 8.5% per annum compounded monthly. That is it. Then doing this now, you understand what will happen. Why are we doing timeline in this type of question? A timeline, it gives a reader, someone who does not want to read the statement, to say what happened from this given statement here. I'm able to read from the timeline as to what happened in the statement here. Now the question says, determine or calculate the future value of his investment. In this case, we want to find out the accumulated amount after a period of what? 5 years. Then, since we have the keyword compounded, it says use the compound interest formula that says A, that is equal to P in bracket 1 plus I, close bracket, all to power of N. We are looking for accumulated. Then A for a period of 5 years. That is equal to, now, each and every amount that we have here is going to run its race until the 5-year period. What do I mean? Let's start with the first amount. The initial amount, it was an amount that is equivalent to 18,000 rand. 18,000 rand. In bracket 1 plus. Then we see from where the 18,000 it is until T5, the interest rate is the same. There was no change in interest rate. Meaning if we have one interest rate, we are going to have one bracket for this particular amount. I'll repeat, one interest rate, it means one bracket for this particular amount because there was no change in interest rate. Then remember, there is a compounding period here, monthly. First, we have to divide this interest rate by 100% first. Then this is going to give us 8.5 divided by 100% first is going to give us 0.085. Divide by the compounding period, it means monthly. Then we are going to divide it by 12 months of the year. Close bracket. Now, how many months are there in 5 years? Because this month, it will be there for a period of what? 5 years. How many months are there in 5 years? Then we are going to say 5 multiplied by the number of months that we have in 1 year. Therefore, there are 12 months in a year. Now, let us create some space so that we are able to to incorporate the second amount that we have here. Then, at T3, there is a further deposit. Now, after the initial deposit, this is a 5-year period for the first initial amount. Now we come to T3 here. At T3, there was a further deposit. How do we indicate this further deposit on our calculation? We just have to indicate it with A plus. A plus what? 15,595. Now, this amount, we can't just say plus. From where it is until where the investment ends, this amount is going to gain interest on its own. Now we need to calculate also its interest. How do we calculate its interest? Therefore, we are going to indicate that with the bracket to say the interest rate is the same. 1 plus, remember it is still 8.5% compounded monthly. Then we still have 0.085 divide by 100%. Divide by 12, not by 100%, divide by 12 because there are 12 months in 1 year. Now here we can put 5 multiplied by 12. Remember from T3, this money it was deposited at year 3. From year 3 to year 5, there are only 2 years left. Then how many months are there in 2 years? We are going to say 2 years that is left from T3 to T5 multiplied by the number of months that we have. Sorry. We are going to have 2, which is 2 years that is left from T3 to T5 multiply by 12 months of the year. Then accumulated amount after a period of what? 5 years. What needs to happen? Substitute the entire thing on the calculator there. 18,000 rands in bracket 1 plus 0.085 divided by 12 all to power of 5 multiplied by 12. Then plus 15,595 in bracket 1 plus 0.085 divided by 12 all to power of 2 multiplied by 12. This gives us an amount that is equivalent to 45,965.17 cents. This is the total amount that Ulrich will receive after a period of what? 5 years. Then we have covered the entire paper. Those with question, address, please do post your questions via the comment section. Then I will be able to address all the questions that you may have. Thank you so much.